What is up everyone? Today, I'm going to share my solution for one of Codechum's medium difficulty challenges, the spiral matrix. Let us first start with including the header files that we need. I said files as plural, but we actually only need printf and scanf functions. I'm going to put the size of my matrix in an integer variable named a. We are going to tell the user to enter the size of the matrix. We're going to accept the input and store it in the memory address of variable a. We are now going to create an integer array that has rows and columns equal to the user input. Now we're going to output the label for the spiral matrix. Now, let's create an integer variable that will start with 1, just like the spiral matrix examples. This integer variable will serve as a counter that will increase until we reach the value of size times size. Now, let's create a loop that iterates size times. This is because we should spiral from the outside to the inside, which is equal to the size. Before we continue with the code, let us understand the game plan. First we will iterate in the first row, from the column 1 until the second to the last column. Next we will iterate in the last column, from row 1 until the second to the last row, and then we will iterate in the last row, from the last column until the second column. Lastly, we will iterate in the first column, from the last row to the second row. This then ends the first iteration and the matrix have now become tighter. You know what else is tight? My schedule. What were you thinking? Comment in the comment section below. Anyways, now we are going to start iterating in the second row, from the column 2 until the third to the last column. Then we're going to iterate in the second to the last column, from the second row to the third to last row. Then, we're going to iterate in the second to the last row, from the second to the last column until the third column. Next, we are going to rotate in the second column, from the second to the last row to the third row. Anyways, you guys get the point. I hope so. Let's start iterating from left to right. We'll put integer j equals I, because we want it to start lower as I increases because it gets tighter. We want it to end before size -1, because that is the second to the last index, but we subtract I as it gets tighter as I increases. Let's put a condition here where if b becomes higher than size squared, it breaks out of the loop. This is because size times size is the highest possible number in a size times size matrix. We want the row to only increase every iteration of I, while the column changes every iteration of j. We will set that element equals to b, and then increase variable b by 1. The reason why we want the row to only increase every iteration of I, is because the row is constant while the column moves. Now, we are going to iterate downwards. This time, we want column to be constant while the row changes. This is why the row will be set to j and the column will be set to a -1 I, which is the last column, which will get tighter every rotation or iteration of I. Before we go to the next traversal, let's put labels first. This is for the downwards traversal. Now we're going to traverse from the last row, which is constant, while the column decreases. We'll put size -1 because it is the last row, and then subtract I because it gets tighter every rotation. The column will be size -1, which is the last column, then -j because it decreases every iteration of j. Let's label it to the left. Now let's traverse upwards, where the column will be constant and only changes every iteration of I, and the row decreases every iteration of j from the last row. Let's label this upwards. Now that we're done with the traversals, let's print the array. Now let's try running the solution. Let's say that the matrix size is 3. As you can see, when the last element is in the middle, our solution will fail. The reason for this is because our algorithm stops at the second to the last column or row. And if you think about it, the center is the last column and row, therefore our algorithm will stop. Therefore, we have to put a condition when we reach the center. Remember that the center is the last element, which is size times size. We will put I as row and column because the integer I represents how many times we already spiraled, and the row and column of the center is equal. Let's now run our improved solution. Hooray! Let's check all other test cases. Our code has accomplished all test cases. Thank you guys for watching. Please like, comment and subscribe. Codechum, please sponsor me.